Evening, I'm Spot On Weather meteorologist Matthew Euler. Welcome to my latest video, and this one is primarily just going to be like a forecast update video. This effective 8 December 2023, and I'm looking at the 12Z data from the modeling as far as this forecast update goes. So of course this is going to change. It may change slightly by the time you watch this video. If you watch it, let's say tonight or tomorrow, models are always in a state of change. If we look at our title slide today, this is really what it's about in the wintertime anymore. We have the heat miser on the left. Over here, heat miser with that evil looking grin or the evil expression, always trying to sneak in there and dash the winter snow lover and cold, real winter weather lovers in the east their dreams, versus Jack Frost over here on the right. So he's going to be bringing all the cold. This one is going to be punching the cold north and trying to take over in the winter where he does not belong. And yeah, it's a constant battle back and forth between warm and cold in the wintertime across the U.S., it seems these days, especially in the month of December. Let's go ahead and kick things off. The overview of today's video, I will take a look at the latest stratospheric polar vortex updates, QBO updates, the sea surface temperature SST anomalies, teleconnections. I'm going to look at the latest forecast for the PNA, the NAO, AO, EPO, and MJO, and then we'll look into some of the modeling aspects. First, starting things off with the stratospheric polar vortex forecast, courtesy of Zach D. Lawrence here on the left. Generally showing, this upper left graphic shows the zonal mean zonal winds at 10 millibar level in the atmosphere, way high up above the ground at about 60 degrees north latitude. This is the update as of today, 8 December, showing kind of like where we're at as far as these zonal mean zonal wind speeds here on the y-axis, range from 10 to 50 meters per second, and the date here on the x-axis going out to about the 25th, right around Christmas time period. And so we kind of see a little bit of a history up to this vertical white dash line. That's today's date, the 8th of December. And we've seen a step down or a slight weakening of these zonal mean zonal winds recently in early December, at least to the first week of December. And then these zonal mean zonal winds, they kind of leveled off basically. And over time, some of the modeling is showing a little bit of an increase in the zonal mean zonal winds, a drop off again between the 13th and 14th of December, and then another increase in the zonal mean zonal wind speeds around mid-December, and then a slight drop off again. So according to this data, we don't really see any significant changes as far as strengthening or weakening of the stratospheric polar vortex based on the wind speeds alone. Bottom line is when these wind speeds increase, we have a strengthening polar vortex in the stratosphere. When these winds decrease or drop off, we have a weakening stratospheric polar vortex. Over here on the bottom left, I'm showing you the 60 to 90 degree north latitude average temperatures in the stratosphere at 10 hectopascals, showing a drop off or a little bit of a cooling of the stratospheric temperatures is the latest modeling right on through mid-December, slight warming between the 15th and the 20th, and then kind of leveling off. If we look at the graphic here on the right, we've recently had some stratospheric warming occurring, right in this zone here, the first week of December. Prior to today's date, the 8th of December, we have had some warming in the stratosphere. What happens when you get a little bit of warming in the stratosphere, you can actually get the polar vortex to stretch out and become more elongated. That's exactly what we're showing here on the right with the graphic. Now this is the forecast over here for Thursday the 14th of December. So this would be next, that'd be next Thursday, showing the white lines here, the height contour showing a stretching. You can see how these white solid lines are kind of elongated. That's indicative of a stretching out of the polar vortex. And, looking at the modeling early today, it almost appeared as if we'd see some of that stretching going towards Europe initially, and then eventually, as we work towards the third week of December, really start seeing some of that stretching of the vortex extending down into eastern North America. course, this is very much subject to change, so that's what it looks like today, but we could all wake up tomorrow morning and things could be different. But this is the latest forecast showing a stretching vortex. And why are stretching vortexes so important as far as the stratospheric polar vortex? It has to do with whenever you have a stretching vortex, per research conducted by Dr. Judok Cohen and et al., you get a stretching polar vortex. You generally is associated with colder temperatures in eastern North America. Let's take a look at the latest QBO update, quasi-biennial oscillation. It's a mouthful to say, but generally this is the update. This is the latest one I could pull. The Singapore radio sound observation for the zonal winds in meters per second are shown here. Generally, this was from yesterday, the 7th of December 2023. We're in an easterly phase. See where the blue solid line is? It's to the left of this line right here, this pressure level line here, going all the way up to 10 millibars in the atmosphere. But generally, we're showing the blue line is to the left of this main line here, indicating a negative value. See this y or the x-axis down here, the horizontal axis? The blue line is generally in the negative value territory over here, indicating a negative QBO. Now, the current value for the QBO, I did a little lookup on this, is negative 19.80. And I went back to look at a couple previous El Nino winters to this one. The 2009-2010 winter was an El Nino winter. The ranges between December to February, the values of the QBO on the negative side, we had an easterly QBO in 09-10 winter, just like we do this winter. The values range from negative 13.83 to a negative 16.98. And then when we look back at the 2015-16 El Nino winter, we had a westerly or positive phase of the QBO, positive 12.79 ranging down to positive 9.34 in the 2015-16 El Nino winter. So just kind of wanted to compare where we're at now, minus 19.80, where we were in December of 2009, we were at minus 13.83. And then also December of 2015, we were completely on the opposite side of things as far as the sign goes, positive or westerly QBO at 12.79. If we look at QBO values, generally if they range between negative 15 and negative 20 in the months of December, January, and February. So we're expecting these values, generally they're right around minus 20 if we just want to round up. What happens when you're around minus 20? Okay. What happens? You generally have anomalously colder than normal temperatures from the Midwest right to the East Coast, even down to the southern U.S., as well as stretching to the eastern seaboard. The coldest core is back over the upper Midwest. Whenever you have QBO values in this range in the months of December, January, and February. One bigger thing to mention about the easterly phase of the QBO, it tends to disrupt the stratospheric polar vortex much more frequently during the winter season. This very well could be a factor in as to why we've been seeing a fairly weakened polar vortex. We haven't really seen the polar vortex really take off in strength and become really, really strong. So the easterly QBO may be doing some of its work. That connection, that research that's out there for the easterly QBO. Whenever these values are negative, it's easterly QBO. The winds are basically blowing from the east in the stratosphere over the equatorial area. So that could definitely play into the strength of the stratospheric polar vortex. Looking at the latest sea surface temperature anomalies as of today, Friday, 8 December 2023, we distinctly see the El Nino signature above normal waters indicated by the orange coloring here off the west coast of South America in Niño 1+2, extending westward all the way to Niño 4, the central equatorial Pacific. We also see above normal water temperatures across the Northwest Pacific. This really has not changed much over the past 3 to 4 weeks. And then right along the U.S. West Coast, we're not seeing much of a signal of below normal water temperatures. It's actually running slightly above normal from off the coast of Washington State down to California coast. And we still see some remnant below normal, slightly below normal waters to the southeast of the Hawaiian Islands. So these are some of the bigger things here that I'm really following closely. Of course, Indian Ocean. With the positive Indian Ocean dipole, we have the colder than normal water in the eastern Indian Ocean and the warmer than normal water across the western Indian Ocean. Here's a Niño region comparison now. I'm going to start, here is the reference in the upper right. Niño 1 plus 2 is right off the coast of South America. Then you work our way westward to Niño 3 box. Then you have Niño 3 plus 4. And then furthest west for the Niño regions is Niño 4, which is closer to the date line. So let's examine the CDAS Niño, Niño index, ONI, Oceanic Niño Index, using CDAS data today. Look at this drop off. Look at this cooling, considerable cooling that's occurring in Niño 1 plus 2 region here. And this is effective as of 06 Zulu time this morning on December 8th. Look at the drop off that's occurred since late November to now in Niño 1 plus 2, right off the immediate coast of South America. Now, if we look at the bottom right here, I'm showing you the Oceanic Niño Index, ONI Index in Niño 3 region, again, which is just located just to the west of Niño 1 plus 2. And it's kind of increased back in late November, and then it's dropped again a little bit slightly, but really no major changes in Niño 3 region. I mean, it seems like it's one of the more stable areas right now as far as the sea surface temperature anomalies go. So Niño 3 region, you're going to see here in a minute, it is actually the warmest, has the warmest sea surface temperature anomalies right now, Niño 3, right in this location. Now Niño 3.4 rather, excuse me, Niño 3.4 is kind of leveling off again, sitting at around 0.154 degrees Celsius, and it's been pretty leveled off since late November through the first week of December. Yeah, so it's still, indicative of a strong El Nino. Anything in excess of positive 1.5 degrees Celsius is going to be considered a strong El Nino. And we're seeing that right now in Niño 3.4 region. If we look at the bottom right here, this is the Oceanic Niño Index ONI for Niño 4, which is the furthest west box. And that is generally going to be sitting in at a value of plus 1.16 degrees Celsius. So the breakdown, if I were to go the warmest Niño regions, I would start with Niño 3. That is at plus 1.64 degrees Celsius. Then I would go to Niño 3.4, plus 1.54 degrees Celsius. And then I would go to Niño 4, plus 1.16 degrees Celsius, followed by the coolest area, Niño 1 plus 2. Now, here is the latest forecast. This is just recently issued from the NMME model. These are the SST, or sea surface temperature anomaly forecasts, just issued here in early December. All right, so kind of see the legend here at the bottom of each of these images. The brighter orange coloring, or the reddish coloring actually, is between 1 and 2 degrees Celsius above normal sea surface temperature anomalies. And for the months of January and February and March here on the left, we see a wide swath of above normal sea surface temperatures, generally from Niño 3 extending westward, Niño 3-4 through the heart of that Niño region, all the way back to Niño 4 towards the international date line. So we are seeing, now I want to show you something. We're seeing more of a westward push of the warmest waters over time, because over here on the far right graphic here, this is the SST anomaly forecast from NMME for the months of February, March, and April. Look at where your warmest water temperatures are now, the darker red coloring. We have one pool of warm, very warm waters, generally north of the equator, just to the west of Central America. And then we have another area closer back towards international date line. So you notice off this Niño 1 plus 2 region, even the Niño 3 here right along the equator, it looks to me like we have a little bit of shifting warmest SST anomalies further to the west by the time we get to February. That's just what I'm viewing right now. And then also look in the North Pacific. In both graphics, January, February, March, we've got some pretty good above normal sea surface temperatures across the North Central Pacific. In both cases, really January all the way through April, if you look at both graphics combined, we have above normal water in this location forecasted. So that'll be really interesting to follow. So just stay tuned for the latest updates on that. Now, why is this so important that we look at where the warmest SST or sea surface temperature anomalies are located? All right, I did some research a few months ago on this, the east-based versus central-based El Nino criteria. And it really matters where the warmest SST anomalies are located. So let's take a look at this. Here are the boxes again of the Niño regions, just for your viewingship here. This source is NOAA, produced by NOAA. East-based El Nino typically has the warmest water, when we call it east-based El Nino, the warmest water temperatures or the greatest sea surface temperature anomalies are in Niño 1 plus 2 as well as Niño 3. Let me draw this out here. This might be better if I draw it. All right, so generally in this location right here, in Niño 1 plus 2 and Niño 3, if the warmest sea surface temperature anomalies are located in these two regions, that indicates we have an east-based El Nino. If we go to central-based El Nino, that is where the warmest sea surface temperature anomalies are going to be out here, closer to the central equatorial Pacific, closer to the date line. And you also see I included the latitude and longitude coordinates for these respective region or these boxes. Now, if we look at an Eastern Pacific-based El Nino, the jet stream location, okay, there's a difference here. The blue line representing the polar front jet stream, okay, and the orange line representing the subtropical jet stream, all right? So this is during the East Pacific or East-based El Nino, Eastern Pacific-based El Nino winter, okay? Let's take a look at the Central Pacific-based El Nino winter and look at the difference, all right? Both of these jet streams are further south when it comes to a Central Pacific-based El Nino, okay? Eastern Pacific-based, you kind of see where the jets are, okay? Look at where it's located here on this graphic, okay? Subtropical jet, for example, going over New Orleans and over the Florida Panhandle across to Jacksonville. Polar front jet stream basically straddling the line from eastern Tennessee through northern North Carolina. But look at what happens in a Central Pacific-based El Nino. This polar front jet stream is further south, down to southern Georgia. The subtropical jet stream, which typically brings in a lot of your moisture and more of the southern storm track during El Nino winters, is all the way south of Florida. Okay, this is huge. East-based versus central-based El Ninos. Okay, so you're going to have a lot more cold air availability across the mid-Atlantic and southeast. It's going to be colder winters in general with this Central Pacific-based El Nino as compared to an Eastern Pacific-based El Nino, where you're going to get more of the up and down in temperatures right near this jet stream axis. Now, if we went back and looked at East-based El Nino temp anomalies, now we're looking at January to February, okay? We looked at 8 total El Nino events in the winter season, and when we had an East-based El Nino, 4 of the 8 winters were below average as far as temperatures go for the mid-Atlantic. Meanwhile, the other 4 of the 8 winters, the other 4 of those 8 winters had above average temperatures for the mid-Atlantic. So there's a 50-50 chance for either below or above average temperatures when we have an East Pacific-based El Nino. Okay? What happens now if we have a Central Pacific-based El Nino? We examined 13 total El Nino events. 9 of those 13 winters featured below normal temps for the mid-Atlantic. That's quite a few. The majority of those 13 El Nino winters were below normal, had below normal temps for the mid-Atlantic for central-based El Nino. Only 4 of those 13 winters featured near normal to above normal temps for the mid-Atlantic. So in other words, central-based El Ninos generally favor a stronger signal for colder than normal temps for the let me cancel. Oh, sorry guys, sorry. I had that pop up on me. I had to update, so I apologize for that. You never know when these updates are going to go on, right? Anyway, so bottom line here is central-based El Ninos favor a stronger cold signal than central-based El Ninos favor a stronger signal than East Pacific-based El Ninos, Eastern-based. Now, what happens? Now, I kind of mentioned this. I talked about this. Let's go back. Right here. So if these warmer than normal temperature anomalies, the greatest, highest sea surface temperature anomalies shift west throughout the course of the winter, over the winter, what happens? I took an example of what happens. All right, so in 1982-83 winter, this is December 82 on the left. Let me go ahead and go back to this. So this graphic here on the left is the sea surface temperature anomalies for December 82. Orange being above normal waters, a very good El Nino signature. It looks very evident here. Look what happened in December 82 as far as the temperature anomalies. well above normal across the eastern U.S. in December 82 during an El Nino winter, where these warmest waters start off in more of the eastern central or more of the eastern equatorial Pacific. Now, what happened over time? January 83. Now, notice how your warmest sea surface temperature anomalies are shifting further west by January of 83. And look at what's happening to your temperature anomaly chart here on the right in January of 83. Look how warm that winter started out in December 82, where those sea surface temperature anomalies were much further to the east. But as over time, those sea surface temperature anomalies, those greatest sea surface temperature anomalies, shifted more west. And look what happened. I mean, you're getting a much larger chunk of, let's see here, of below normal temperatures now in the deep south, Gulf Coast, up through the mid-Atlantic, okay, by January of 83, as these SST anomalies shift further to the west. What happens in February of 83? You see where the warmest sea surface temperature anomalies are located, okay? And you still see what this temperature anomaly, the air temperature anomaly pattern looked like in February of 83. Below normal from the mid-Atlantic down to Florida, extending westward along the Gulf Coast, including Texas. So this is a real good possibility this winter to happen, okay? We are seeing, some ups and downs in the temperatures right now in December, but when we have a forecast like this, where these warmest waters keep going a little bit further to the west, specifically by February, this is a distinct possibility. We could see these temperature anomalies here, these graphics on the right of each of these slides, actually come to fruition, specifically in January and February, where the cooler than normal temps are from Texas up to the mid-Atlantic. Now let's take a look and examine the latest Teleconnections forecasts, starting with the European EPS, 50 perturbed members. This is for the Pacific North American pattern. And notice the general trend, it's positive from the 10th. It really doesn't dip negative at all, does it? It goes from the 10th to the 23rd of December. See the solid green line here? That's the average of all these ensemble forecasting members, keeping a positive PNA. So European EPS, 50 perturbed member, we're going to draw a plus sign. That's a positive PNA throughout the period. What about the European EPS, PNA, 50 perturbed members? Now this one goes 46 days out in the future. This is going to take you all the way to 21 January. And notice this. It kind of gets closer to neutral right here at the 19th and 20th time period of December. But then it goes right back up to a stronger positive PNA. And then it kind of just remains that way all the way through the 21st of January. So we'll say European EPS 46-day forecast is going to be also a positive PNA. Looking at the NOAA JEFS V12, showing a positive PNA throughout the period. So again, that would favor higher than normal heights across the western portions of North America, and then lower than normal heights downstream across the eastern U.S. We look at the negative, the North Atlantic Oscillation Teleconnection forecast. We're starting off negative today, but we're increasing to the positive side by the 12th and 13th of December, and we may remain fairly positive overall according to the EPS. We look at the EPS, 50 perturbed members, out again to that 46-day forecast all the way to 21 January. We're negative today. We go up to positive NAO by the time we get to the 15th, and then we come down slightly negative at the end of December, and then kind of ride around this neutral line. So I'll go with a neutral overall in the longer range per the EPS 46-day forecast for the NAO. If we look at the JEFS V12 NAO forecast, negative again to start, and then we see a rise or a climb to positive, and it remains positive all the way to the 23rd of December. There are some signs towards the end of this JEFS model run that we could go to a negative trend again. So according to the JEFS V12, we're starting negative, then we're going to go positive with NAO, and then go back negative by the end of the period. So why is it important to look at the NAO phase, whether it's positive or negative? It's simple. Whenever we have an El Nino winter, okay, so we have El Nino, and we're having that this winter, and we combine that with a negative NAO, what happens here? We get a trough. We get a nice deep trough and much colder air across the eastern U.S. You got that positive height anomaly over the top near Greenland. So you got a plus over here, positive height anomalies over a negative height anomaly along the eastern seaboard. And these are the temperature anomalies on the far right. Below normal temperatures is the norm when you combine a negative NAO plus the El Nino. Additionally, you have that suppressed storm track, which is generally, all these areas in the mid-Atlantic are going to be north of the storm track and remain in the colder air. So it's very important when we look at the NAO phase in an El Nino winter especially. Now, if this were to go positive, the NAO, we'd have a whole different story on our hand. We'd probably be looking at more in the way of zonal flow, more Pacific air, or even some potential ridging across the east and milder temperatures overall across the east if this NAO is in the positive phase. Let's take a look now at the Arctic oscillation forecast. European EPS 50 perturb members starting out negative today, and then the NAO climbs to positive before dropping back slightly negative through about the 21st of December and then kind of hanging around neutral territory. So AO negative to start, going positive, and then we go back towards negative to positive, kind of straddling that neutral line. We look at the EPS, the European EPS, AO of 50 perturb members going all the way out the 46-day forecast to that 21 January time frame. We're negative to start, and then we go positive to the AO, and then we come back down negative, neutral, and slightly positive. And so there's a lot of ups and downs per the latest European EPS 50 perturb member longer range 46-day forecast for the AO. And then the JEFS V12 AO forecast showing us negative today, then going positive between the 13th and 15th of December and dropping back down negative in the longer range. So this will be something interesting to watch. And what I want to re-emphasize is that this, the phase of this AO is totally dependent on the strength of the polar vortex. So if the stratospheric polar vortex is weak, we generally tend to get a negative AO, especially if some of that energy propagates back down from the stratosphere to the troposphere. If we get a stronger polar vortex, our AO goes positive with the lowest heights over the Arctic. Here is a look now at the EPO, Eastern Pacific Oscillation Teleconnections forecast, European EPS, EPO 50 perturb member forecast showing a positive phase of the EPO. Now that's not what we want. We would prefer to have a negative phase of the EPO to get cold in the east. But right now we're in a positive phase. We have a very deep Aleutian low pressure system situated in the Gulf of Alaska. We want it to be down here in the negative territory to get the cold. And so this indicator is for, milder temperatures in the east per this latest teleconnection. The European EPS, EPO 50 perturb members, 46-day forecast going up to 21 January, generally showing a positive phase again, dropping down in your neutral territory by the 16th of December, and then going back positive again, and then neutral. So a lot of ups and downs here. And then finally, the JEFS V12 EPO 30 perturb member forecast going out to Christmas Eve, 24 December, starts off positive, very similar to the other two models I just showed you, and then gets back up to positive, and then it goes negative here. More significant difference here, JEFS V12 has got a bigger drop in the EPO, so we'll have to watch that between the 14th and the 20th of December. Let's take a look at the Madden-Julian oscillation forecast now. I'm going to show you two model forecasts from today, 8 December. I'll start with the JEFS V12 here on the left, showing right now on the 8th of December, we are situated in weak phase 5. You kind of see the 5 right here, right? This is the phase 5 area, and we're weak in phase 5 here on the 8th of December. We're going to work ourselves right back into the null phase here between the 10th and the 16th of December, and there are indications that we potentially could come out into phase 7 by the 22nd. We look at the European model here on the right. Right now, the 8th, very similar position to the JEFS V12. We are sitting in a weaker phase 5. That's going to go ahead and collapse into the null phase, definitely by the 12th of December. So that would be, Tuesday next week. And then we just kind of get stuck in the null phase where there's minimal impact from tropical forcings for the convection in the tropics. There's minimal impact from the MJO on U.S. weather in this case. I will remind everybody that during strong El Nino events, the MJO tends to be weaker. That is research conducted from Paul Rondi. He conducted that research saying that the MJO magnitude is much greater or more of a force, the MJO, during La Nina periods, vice El Nino. Here is the latest ensemble forecast now. Let's take a look at these. We'll start off with the Jeff's V12 forecast. The first graphic here on the left I'm showing you are the heights. Whenever you see the orange colorings, that's upper level ridges above normal heights. Where you see the greens and blues, that's below normal heights. So greens and blues, when they're below normal heights, that generally is associated with colder temperatures. The maroon colors, the browns, that's associated with ridges and warmer than normal temperatures. So initially on the 11th of December, we're going to have a trough that's going to really move in to the eastern U.S. It's going to result in a cool down for the mid-Atlantic. This is going to be right behind a very strong dynamic system that's going to roll through the mid-Atlantic on Sunday evening, and it could result in a potential wind damage, very strong wind gusts, and very heavy rain ahead of a strong cold front. The area of low pressure forms along it, and then kind of just moves up towards New England on Sunday. But this is on Monday, the day after, so this is next Monday, a few days out here, 72 hours out. And we have a trough that kind of fills in behind the departing storm system and behind the cold front. Notice this signature on Monday of a very strong upper level ridge into the North Atlantic. So that's something that we'll have to keep an eye on. This could be in the start of a negative NAO again, so we'll watch this closely. By the time we get to next Friday, the 15th of December, this pattern looks fairly mild across much of the United States. Look at the orange coloring across a big chunk of the U.S. next Friday, according to the Jeff's V12 model. We do have some ridging right along the U.S. West Coast all the way up to Western Canada, but we just don't, it just seems like the flow is more zonal here from the Midwest to the East Coast next Friday. So that, normally you would look at a positive PNA here, and we looked at that in the Teleconnections slides. Positive PNA is here, but we're just not getting much troughing downstream into the east by next Friday the 15th. Notice this low. Look at how established that low pressure system is over the eastern North Pacific. All right, so we'll keep an eye on that. And then moving on with the Jeff's ensemble forecast, global ensemble forecasting system, that's what Jeff stands for. This is the 20th of December on the left, showing, again, look at this higher than normal height area across the North Atlantic. This, again, could be a result of a negative NAO, and then we got a little bit weaker, it's a little flatter, but there is still some ridging that is evident here going up from the Pacific Northwest, the United States, and Canada. So this to me looks like by the 20th, we have a positive PNA and we have a negative NAO, okay? And so this seems rather mild to me based on that setup. I believe this might actually trend some colder than what this is currently indicating based on the positive PNA and the negative NAO. If we look at the forecast here on the far right, this is going to be for Christmas Eve, 24 December. Look at the blues now starting to show up across the Gulf Coast, Florida, into the Western Atlantic. And the higher than normal heights are situated generally up here over the North Atlantic, associated with that negative NAO still. We still have some ridging out in the western U.S. It's just not looking good. It's just not looking favorable for you across the western U.S. to get much in the way of precipitation through Christmas. There's just this ridging feature here, and ridging associated with sinking air and no precipitation. This is going to be interesting to watch across the southeast and mid-Atlantic, because this is almost seems like it's starting to show some signs of more of that El Nino-like pattern. We have this blue shading, which generally could indicate storminess in some location here around Christmas Eve. And look how well established the Aleutian low is. This is very typical during strong El Nino winters. Get a very strong Aleutian low, and what does it do? It pumps the heights up here along the west coast of North America, and there you go. That's what we're looking at right now for the latest forecast. We look at the EPS, European Ensemble Prediction System, very similar. I started out with the same starting point. This is Monday, the 11th of December coming up. Troughing in the eastern U.S., cooler temperatures, windy, breezy conditions. We still have that negative NAO signal, higher than normal heights, kind of building across the North Atlantic. We see some ridging starting to make its way into the west coast of Canada. Forecast here on the right showing for 15 December. Look how nicely established this trough is over the northeastern Pacific. And then downstream of this troughing, you got that nice ridge that's developed all the way up into western Canada and eastern Alaska. A little bit of troughing into Texas, a little bit of weak ridging across the Tennessee Valley. And you still have that higher than normal height signature there up towards the North Atlantic. So we'll keep an eye on this and see how things evolve. But this is still on both models, we're seeing that positive P&A signature. It's very evident in this case. And then I wanted to end today's video with some of the other forecasts. Let's see, I think this is the last one I got. I'm going to show you the CFS latest forecast. Now this is for January and February. Whoops. Yeah, my apologies. This is the CFS forecast. I'm showing you what we're looking at for January and February. I must not have had my pen highlighted. Yeah, I did. So for January and February, what are we looking at here? Okay. The latest forecast, and believe me, this changes more than a toddler's temperament. All right, CFS, I look at this with a grain of salt because it changes so very much. But in general, I just wanted to show you kind of what it looks like, where we got, potential storm tracks like this coming in January. Notice the negative NAO with the higher than normal heights here across the North Atlantic in January. That's what the CFS is showing. So that would be a nice look. We can get the storms to kind of move underneath. We do have a little bit of ridging up to Alaska at this point. So, I mean, this could ultimately result in more of a negative EPO signature by January, which would be a good signal to send this cold further east. And then over here on the right is the CFS monthly forecast for February. Now, look where the lower than normal height set up now. And by the way, this is an agreement with the European latest seasonal forecast that was just issued the other day. So, see the ridging across the North Atlantic again. That's at negative NAO. We got the negative over there. I'm sorry, the positive. The positive heights over here in the North Atlantic associated with the negative NAO. And then you got the negative height anomalies along the eastern seaboard. So this would be your favorable area for storm development and movement. And look at this P&A signature. Ooh, boy. This would be a good one. The troughing is far enough west so that allows these heights to rise out ahead of that trough, okay? If this stays fairly stationary further to the west, that's a good thing for us. If this trough were to be closer in pulling into the west coast, that would not be good for the eastern U.S. because we pump a ridge up to the east. So really, it's the wavelengths of these waves, where do the troughs and ridges set up, and that's what really matters. All right, that is all I've got. I kind of put a crash course presentation together today. Believe me, I'm working on time constraints today, but I want to get a new video out. It's been a while. I don't know where the time is going. It seems like it just flies by. But anyway, that's all I've got for now. I'm going to keep an eye on things. You can always follow my latest forecasts and updates either on X or also the Spot On Weather Weebly page. I update things regularly there. And that's all I got for now, everybody. Until next time, take care and God bless everyone.